2.1 Basics of Function and their Graphs, Day 2. So for this part of the lesson, we're going to graph functions by plotting points. We're going to use a vertical line test to identify functions, obtain information about a function from its graph, identify the domain and range of a function from its graph, and identify intercepts from a function's graph. So first thing, the graph of a function is the graph of all of its ordered pairs. So example 1 says we're going to graph the functions f of x equals 2x and g of x equals 2x minus 3 in the same rectangular coordinate system, selecting integers for x starting with -2 and ending with +2. Alright, so the first thing I'm going to do here is I'm going to build a table. And so I'm actually, okay, so let's build a table. Sorry about that. And so my first one is for f of x equals 2x. Alright, and it told us to use x's that are -2 to 2. So remember, this is your x and your y. So we're going to use our x's from -2 to +2. Now remember, you plug in the x to solve for y because f of x is the same thing as y. So this is like y equals 2x. So we know that this first y value we're going to pick is going to be that 2x, but now my x is a -2, so it's 2 times -2, which is -4. And then the second y value, since it was 2x, is 2 times now x is a -1, so -2. And then 2 times the 0, which is 0. 2 times 1, so we get 2. And then 2 times 2, so we get 4. And so we have this group of ordered pairs. But now remember, it just told us to use integers from -2 to +2. It could have kept going. So when we draw this, we're going to put arrows on both sides. Alright, then we're going to graph g of x, which it told us g of x is equal to 2x minus 3. Well, remember, g of x is the same thing as y equals. So we're going to do the same thing. We're going to build a table here. My x's, it told us to use -2 to +2 still. And then I'm going to plug in my x's to solve for my y. So this first y here is going to be 2 times that x, which is -2, minus 3. Well, 2 times -2 is -4, minus 3 gives us -7. My second y value is going to be 2 times that second x, -1, minus 3. 2 times -1 is -2, minus 3 is -5. My third y value is going to be 2 times the third x, which is 0 minus 3. And then 2 times 0 is 0, minus 3 gives us -3. My fourth y value is going to be 2 times my fourth x, which is 1, minus the 3. 2 times 1 is 2, minus 3 is the -1. And then my last y value here, we're going to plug in that last x, which is 2. We're going to do 2 times 2, which is 4, minus 3, which is a +1. Okay, so now that we have our tables, I'm going to move to the next slide where we're actually going to graph them. Alright, so just to kind of recap what we had, for our g of x equals the 2x minus 3, we had a table that had the ordered pair of -2, -7, -1, -5, 0, -3, 1, -1, and 2, +1. And so I'm going to go ahead and graph that one. So -2, -7, -1, -5, 0, -3, 1, -1, and 2, 1. Now, using what you've known in the past, hopefully you realize it's going to be a linear line. And so we're going to go ahead and connect our dots. I'm going to extend it. And then make sure you put arrows on it because it does keep going. Now, remember, we also had our f of x, which was equal to just the 2x. And we had a table for it that had the ordered pairs -2, -4, -1, -2, 0, 0, 1, 2, and 2, 4. And so we're just going to graph those points. So -2, -4, -1, -2, 0, 0, 1, 2, and 2, 4. And so there is our two graphs. All right, the vertical line test for functions. It says if any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. So remember, we're going to take a vertical line, which is a line that goes straight up and down, and we're going to check our graph. If it crosses more than once on any line, not a function. All right, and so here in example 2, it says use a vertical line test to identify graphs on which y is a function of x. And so I've already drawn in the lines here for us, so we just really need to look at it. So look at the first one there. So we have our vertical line, and it doesn't matter if we chose that point or if maybe we use that point or that point or that point. If anywhere on this graph, if it touches the graph, each line touches more than one time, this is not a function. So just using the one that we're given here, when I look, I notice it touches here and it touches there. Therefore, this is not a function. Now, when I look at the next one, it doesn't touch more than once where it's at, but I need to make sure of all the locations. Is there anywhere here that it doesn't touch more than once? There's not. Every line that we can draw on this line will only touch our graph one time. Therefore, this is a function. And so I stress that because what if on this first one, if they had chosen this place to draw the line, it would appear to be a function. It only touches that vertex there one time, but that's not true for the rest of the graph. Anywhere else on the graph it touches twice, therefore it's not a function. All right, and so example 3, we're just analyzing the graph. So it says use the graph to find f of 5. Well, remember, we usually see this written as f of x, but now we're looking for f of 5. So therefore, I'm looking for what is the answer when x is 5. So we're going to go to our graph. We're going to find where x is 5. So go on your x-axis, find where x is 5, go touch your graph, and tell me that y value. That y value is 400. So we know that f of 5 is equal to 400. Now it also says for what value of x is f of x equal to 100. Well, remember earlier I mentioned that f of x is the same thing as saying y. So we're looking for where y is 100. So let's go to our y-axis. Go find where y is 100. So it's somewhere right in here. We're going to go over and touch our graph. And then what is that x value right there? And that's when x is 9. Now to identify the domain and the range from a function's graph, it says to find the domain of the function from the graph, look at all the inputs on the x-axis that correspond to the points on the graph. So we're going to label all of our x's. But guys, because they're lines, we can't just put numbers, okay? So we have to tell it where it's going to start at and where it's going to stop at on our graph. And then the same thing for the range. The range is the outputs. It's our y's. So for the domain, we're going to look left and right. So we're going to look left to right because smaller numbers are on the left. And for the range, we're going to look from the bottom to the top because remember, our smaller numbers are at the bottom. All right, so example 4 here says use a graph of the function to identify its domain and its range. So let's look at the domain. So for our domain, we're looking at our x's, so we're going to look from left to right. Well, notice it starts right there at the -2, and it's going to end, so my graph keeps going all the way from that -2 to right here, which is when x is 1. So we know it's going to be from -2 to 1. Now let me erase my lines here. Look, though, we got to decide, are we going to use a parenthesis or a bracket? Remember, this comes back from a previous lesson. At the -2, it's got that closed circle. It's equal to, so we're going to use a bracket. And at the +1 right there, it's also got a closed circle, so we're also going to use a bracket. For our range, I'm going to change colors here real quick. So for the range, we're going to look from the bottom to the top. So let me erase what I have here. So when I look at the bottom, I notice my graph starts right here when y is 0. And it's going to go all the way up to right here where y is 3. Remember, we're looking at the y values there. Alright, so when x is 0, we notice that it's a closed circle, so it's going to be a bracket. And when when y is 3, we notice it's also a closed circle, so it's going to be a bracket as well. And so there is our domain and range for this graph. You're looking for the domain, you're looking at the furthest left point to the furthest right point. And for range, we're looking from the bottom point to the top point. Not necessarily always going to be the ending, okay? Because this graph here could have dipped back down or something, and let's say it didn't end to here. So therefore, my range would still be the same because it's my bottom to my very top point there, okay? So what about this one? We're going to identify its domain and range. Well, for domain, remember that's our axis, so we're going left to right. So I notice my graph starts over here when x is -2. And then that line's going to keep going all the way to here to where x is 1. Now, when x is at -2, I notice that's an open circle, so I'm going to use a parenthesis. And when x is 1, that's a closed circle, so use the bracket. Then for my range, we're looking from bottom to top. So notice the very bottom point is right here when y is -1. And it goes all the way up to here when y is 2. When y is -1, it's a closed circle, so we're going to use a bracket. And when y is 2, it's an open circle, so use a parenthesis. So there's my domain and range of that graph. Now, x and y intercepts. So to find the x-intercept, you're going to look for the points at which the graph crosses the x-axis. So we're just looking for where it crosses the x-axis, and there can be more than one, okay? So to find the y-intercept, you're going to look for the point at which the graph crosses the y-axis. Now, if this is a function, it's only going to have one y-intercept. And that's what it says next. It says a function can have more than one x-intercept, but at most one y-intercept. So when we look at this graph here, so look for your x-axis when you're looking for your x-intercepts. Does it cross the x-axis? It does. It crosses it 3 times. Okay, so my x-intercepts are, I'm just going to go from left to right. I can see it crosses right here when x is -3. So if we're going to write that as an ordered pair, that would be -3, 0. It also crosses right here when x is -1. So that would be -1, 0. And then it's going to cross again right there when x is 2. So it's also crossing at 2, 0. Now for our y-intercepts, we're going to find our y-axis. Alright, so look at your y-axis. Does it cross the y-axis? It does right there when y is -6. So my ordered pair is going to be 0, -6. And so there's our x and y intercepts.